Oh, with Carmen?
Yeah. Okay, so we've got 16, 15. Seth again, is it this area?
Yeah, wait. Yes, that's it.
Okay, so is it 15 and 16 right there? Or is it another 15?
Just 16.
Just 16. Okay, so Carmen has a painting presently valued at $5,000, and our dealer told her the painting would appreciate at a rate of 6% per year. In how many years will the painting be worth $8,000? So this is just going to be I call it a basic growth model is really what's going on here. So let's look at that. I don't know what's going on there. Okay, so it's going to be in the form y is equal to a times b to the x. Where here, because it's a growth, b will be 1 plus r. So it's simply going to be y is equal to the starting amount, or what it's worth originally, which is 5,000. And it's appreciating at a rate of 6%, so it's going to be 1 plus 0.06. Obviously, that's just 1.06, but I'm going to write it like that to show you the 1 plus r. And then the exponent is going to be our unknown if we're just trying to figure out how long it takes for it to grow to 8,000. Okay? Now, it's kind of weird. Write a logarithmic expression. So let's start with this, and then we'll figure out what the logarithmic expression is. Okay? So 5,000 grows to 8,000 at a rate of 6%, and it let me erase this. So we're solving for our x. Okay, so here's the question. How did I know to use y equals a times b to the x? Or did you know to do that?
Yeah. Yes.
Okay, good. Because we have several growth models, right? Okay. We have our PERT. And PERT is when you see the words compounded continuously. PERT. Or we also even have a compound interest formula, which is when you see compounded by order or something like that. Okay, so let's keep going. I'm going to divide both sides by 5,000. Okay, so when I do that, I would simplify down to 8/5 is equal to 1.06 to the x. Did I do too much, or y'all go with that?
Good.
Okay, then I would take the log of both sides, or ln, either one's fine. I usually just do the log here. So log of 8 over 5, okay, and I have to take the log over here as well. Let me scoot this over a little bit. Okay, so, and then when I take the log, I can bring the x down front, which is the whole point of taking log of both sides. So then the x will come down front, and I have log of 8/5. And I'm not wasting my time even plugging that into the calculator yet. I'm just writing it all down. So x will be out front. So x is going to be, when I end up dividing, I divide log of 8/5 by log of 1.06. Now, that may be the answer. I can't remember what the key said. Or could I rewrite it a different way? Could I use the change of base formula? Wouldn't it be log? And remember, this would be on top, so it would be 8/5. And then my base would be 1.06. So this is the same exact thing. That's the change of base formula. So do y'all remember what the key said? I have a key right here. Let me just grab it real quick.
Would you accept either answer?
I would accept either answer, and it is kind of a strange question, actually. So simplify your expression. Let me see what the key. What's that? I mean, the concepts, yeah, would be on the quiz, but I think we would just probably ask you to solve for the time. So that's the next part. So I'm literally just going to plug this into the calculator. This would be what I would consider exact. And then when I simplify it, the approximate answer is going to be 8.06 years. So most of the battle, like most of the process, is just getting it set up correctly, but then the calculator can, cause you to stumble some, so make sure you know how to do it on the calculator. Okay, there's number 16. Tell me another one.
Number 33.
33. Now is it down or is it up?
It's up.
Up.
It's about 8.6.
This 33?
8.6.
Okay, number 33 right here. There's a couple of things you could do. I think I would probably bring the power 4 out front and multiply by log base 9 of 27. Now log base 9 of 27 is not something that we know right off the top of our heads, but could you kind of think about what do you do to 9 to turn it into 27? Well, wouldn't you first take the square root of it to turn it into a 3, and then you would cube it to turn it back into the 27? Okay, so it's going to be 4 times, and I said we would first take the square root and then cube it. So it's going to end up being 6 is the answer. Now, I did a lot in my head, so let me show you how you would do it if you want to write it all out. I still like that approach, so 4 times log base 9 of 27. Now here's where I can either rewrite this piece right here as an exponential and simplify using changing to a common base, or I can use my change of base formula. So let me show you, I think that's the easier way. So this is log of 27 over the log of 9. A really neat little way to approach things. And then I'm going to insert a base of 3. 3 here, 3 there. So this is going to be log base 3 of 27. What is that? What is log base 3 of 27? 3. What's log base 3 of 9? 2. You get the same answer either way, because that's going to simplify down to a 2. So either way you get a 6.
So you can insert any base.
You can insert any base as long as you use the same base in both the numerator and denominator. Okay? And Rosie, do you have a question?
Yeah. Like anywhere where the log of something minus or plus log of something equals a number, like 42
Okay.
and 45 and 46. I just
Okay.
blanked.
Okay. All of those are basically where you want to get down to a log equal a number, and then you rewrite as an exponential. Any of those, but let me do a couple. So which one should we do?
46.
46? Okay, so here we are. So I'm going to say log, and then because this is subtraction, I'm going to say 9x plus 1 over x squared is equal to 1. Now, what some students want to do is just drop the log like we do for the equality. You can't just drop that log. You have to actually rewrite it. So you have a base of 10 here, understood. So 10 to the first is equal to all of this. So 10 to the first is equal to 9x plus 1 over 10x squared. Now from here, I would multiply, oh, it's not 10x squared, it's just x squared, sorry. And then I would multiply both sides by 10, not 10, x squared. I'm thinking ahead a step. Cancel, cancel. So then I'd have 10x squared on the left side here. So then what would I do? Yes, this is a quadratic. So 10x squared minus 9x minus 1 equals 0. Okay. And then are there factors of negative 10 that add to negative 9?
Yes.
Okay. This is a little bit different though. I have to do some trial and error, but it's not too bad. So 10x squared, what do y'all want to try? 10x and then 1x like that. And then this is obviously just a 1 and a 1. I don't have any choices there. So I want negative 9x, which means I need the bigger one to be negative. So when I do my outer, that's a negative, that's a positive. Now I'd set those both equal to 0 and solve. This would give me a negative 1/10. This one right here would give me a positive 1. And those are the algebraic solutions. But do they both work?
No.
Okay. Because if I put in the negative 1/10 here, it won't work.
He did say that both of those worked, though. I had a question on that because it said that, like, it didn't just specify that one was the only solution.
Well, wait a second. If I do, it will work, actually. Yeah. So I do 9 times negative 1/10. That's a negative 9 over 10. So negative 9 over 10 plus a 1, 10 over 10 is 1/10. it's positive. So they both do work.
That's some shit stuff.
Because a log
That
just
is, what's that?
just overall lines log.
You cannot take the log, so whatever's inside here, what I'm circling, cannot be negative. So when you plug in your x's, so the takeaway from that is it is not just a hard and fast rule that if you get a negative solution, it doesn't work. You have to plug it in, and depending on the equation, sometimes the negative does work, sometimes the positive won't work. It just depends on the equation.
Negative, like negative 1/9, that would give you log of 0, so that wouldn't work either, right? Wait,
Neg-
no, never mind, no, that would give you 1. So like negative 1/9, would that work?
Oh yeah, if it gives you a 0, it won't work either.
Okay.
You have to have a positive
Right.
number, not neutral, not negative, positive to take the log. Yes.
So, when do you keep, like, when do you drop, like, the 10, when do you keep, like, the 10 under the log? You say you drop it at one point and then you keep it.
Okay, so this is the question here. When you have a problem like this, you see you have logs on one side and a number on the other side. 43, if you look right above, I have logs on the left and logs on the right.
Now drop.
And when you can get to that point, you can just drop the logs. It's because of the equality property of logs. So if log of m equals log of n, and they have the same base, then m equals n. Okay?
So for 46, did you just added the log over?
No, because you still have that number. You still have the number. It has to be a pure log equal to a pure log. You can't have anything else. You can't have anything out front. Okay? Multiplied by. If you have that, you bring it up as a power, and then you can do something with it. Okay? Yes.
So how did you turn the log into like a 10?
Okay, let me show you. So it's an understood 10 here. So I rewrite it like that, where I just draw it there, and then I'm looping around like that. So 10 to the first is equal to the result. I will tell you that is one of the #1 mistake areas for students. So remember, you have to analyze it when you get it. So I'm going to walk you through that real quick. There are 3 different types of problems that we're looking at up here. This doesn't have any logs. It's an exponential. And you have exponents on both sides. So this you could solve a couple of ways. Changing to a common base, okay? Or I could take, and that one would actually change to a common base. If it won't, let's see if there's another one. There's not another one. If it will not change to a common base, then you'll want to take the log of both sides and bring your powers down. Okay, that's usually the way you would want to do it. Okay. So there are no logs. When I look at number 40, I do have logs. They're on the left, not on the right. This is going to have to be a rewrite where I do 4. Well, and I might simplify it a little bit first, but it'd be 4 to the 15th is equal to all of that. So you're looping around. Okay.
You have to
So
move
see
that.
how 39 and 40 look very different. So know the approach for each of those.
Can you
Yes.
do number 39? Like not the
39.
change in the base way?
Okay, not what?
Not like the change in the base way.
Not the change the base way. It's going to be the easiest, but we could do it the other way. So I would take the log of both sides. Isn't this really just 64?
Yeah.
So that helps a little bit. Okay? So I would take the log over here, and then the x plus 5 would come out front. So x plus 5 in parentheses, and I have log of 1 over 16. And that equals log of 64. So now I divide both sides by log of 1/16. Log of 1/16. I would get all of this, and then I would subtract 5. That is an exact form, but you plug it into the calculator to get the approximate.
Can't you also just change the base to 3?
Yeah, you know, when I see it like this, let me show you what I do here. It almost forces us to change to a common base at the end anyway. Very good question. So, is there a common base here? 2. Okay, so I put a 2 there, and I put a 2 there. And don't forget, I still have my subtract 5 after that. What is log base 2 of 64?
5.
6.
6. Okay? Because you just have to kind of think 2 to the 3rd is 8, then 2 to the 4th would be 16, 2 to the 5th is 32, so it doubles. And then what about log base 2 of 1/16? This is a little trickier.
-4.
So I need to raise it to the 4th power and put it in the denominator, so yes, it would be a -4. So I have a negative 6/4 minus 5, and that would be your answer. Now you'd want to tidy it up a little bit. So yeah, let's do it. If y'all want to do it, we can. So this would be minus 20 fourths. So I get a negative 26 over 4, which is going to simplify down to negative 13 halves. Now I don't remember if this is where you, do you have the calculator on this part? Like you just have, well, I don't know what section we're in. I don't think you have the calculator in this part. So now to me, that answer or that process would have been much simpler just to change the base right off the bat. Because see all the work you had to do on the back end? So maybe just change to a common base. If you can change to a common base, it's usually going to be your best route. Okay? Tell me another one.
You number 43.
Right here.
Yeah.
So 43,
Drop the log.
there's logs on both sides, and it's already down to a log equal to a log. So I just say x squared minus 9 equals 5x plus 5. So this is going to be a quadratic where I want to move everything over. So subtract the 5x, subtract the 5, and it joins over here, and I get 0. Now, will this factor? Factors a negative 14 that add to negative 5. 7 and 2, and the 7's negative. So my solution algebraically is 7 and negative 2. Do they both work?
No.
No. Which one doesn't work?
The negative 2.
The negative 2. Now guess what? It works here fine. So you always have to test both. It does not work over here. So this is not part of our solution. So test them always. Another one?
Do you remember 9 on the next page?
Do I scroll down?
Yeah.
Okay. All right, so on this one, so analyze it first. Remember there's 3 types. Exponential equations that don't have any logs involved at all, and you use logs to solve. Where you have logs on one side but not the other, you rewrite. Or when you have equalities where you just drop the logs, log equal log. This is which one?
A log on the side.
Log on one side. So I do want to kind of tidy this up a little bit. If I subtract 4, because I want to get the log all by itself. So that's my starting point. Okay, and then I get what over here? A 1. Now,
Divide by 3.
I can divide by 3 here, only because there's just a number on that right side. If I had a log, I can't do that. So I probably would divide both sides by 3, getting rid of this. Now it's log equal to a number. It's a rewrite. So when I say rewrite, I mean I have a base of e. I'm going to loop around. E to the 1/3 is equal to x minus 3. So x is going to be equal to e to the 1/3 plus 3, and you leave it just like that. Okay, another one. Now, if you need me to slow down, just say, wait, I don't get it, please. But I'm going to keep going so we can do as much as
So
possible.
you when you have that, you take what it equals to and put it. Okay, I got.
So when you get down to a log equal a number, this number is an exponent always. That's what logs are, right? So if you just rewrite it with your base to the power and the result kind of looping around, that's not mathematical, guys. It's just kind of a little thing you can do. It'll help you out. Okay? Yes, Seth?
Will you have a copy of the key that I can look at?
Yes, there's one. Well, actually, I have it right here. Sure. Okay, another one? Yes.
On number 12 on that sheet, right there,
Uh-huh.
on the key, and like this is how I solve it too, you have to do the quadratic formula, but like with the quadratic formula, it's like negative 3 plus or minus 8 square root of 85 over 2, which like doesn't really like solve to a number. How do you know that the negative one still works? Because like the key said that
So tell me what the answer is again, and we'll go from there. Unless somebody needs me to do that from start to finish. Y'all need it?
I think we did it
Okay.
yesterday.
Did we?
No,
we didn't do this one.
So basically, I'm going to go ahead and multiply this by this and set it equal to 9. So multiplying, I've got x squared, 5x minus 2x is 3x minus 10 equals 9. So I'm going to subtract the 9 over. X squared plus 3x minus 19 equals 0. And that's not going to factor, so yes, I'd have to do the quadratic formula. So x is going to be equal to a negative 3 plus and minus 3 squared is 9 minus 4 times a times c. okay, all over 2a, and a is just a 1. So I'm going to get -3 plus and minus, and that's going to be what?
Root 85.
Okay, so 85, and then I'm going to do over 2. Now, what I need to figure out is when is the square root of 85, when it's positive, what does it give me when I add it to the -3, and when it's negative, what does it give me? So the square root of 85 is going to be a tad bigger than,
9.
okay, yes. So when I do -3 plus 9, I'm okay.
Yeah.
When I do -3 minus 9, I'm not. So the answer shouldn't be both. It should be -3 plus and minus the square root of 8. No, I just said shouldn't be, and I did it. Plus the square root of 85 over 2.
So you should write it with just a plus at the end because that's the only way that would work.
On this one. Now, what if it, no, you gotta listen. So what if this was different? I mean, I'm trying to think of a case where the subtract, if you had a negative down here, but you wouldn't end up with that because you would not leave your 8 negative. So you just have to make sure whether one of them's negative. If one of them is negative, then you're not going to use that. Wait a second. We still have to plug it back in. So this would be, think about it, this is -3 plus something bigger than 9, right? So it's going to be
Like 6 over 2.
6. Okay, so something a little bit bigger than 3.
So what's that
So
work?
it works here and it works here. Yeah, it works both. But you do have to check it out and make sure when you plug it back in, it's still good. It can have no solutions.
How?
Because neither, like algebraically, it will have a solution, but when you try to use it as part of the log function, it won't work. That's what it is. Yes?
Do we need to write the exact announcement for the customer?
This is the calculator part, right?
Yes.
Just follow the directions. For one like that, I would probably leave it in exact, and let me tell you why. It's not like an application type problem. You know, application problems you're solving for time, that kind of thing. You try to get it down to the actual seconds or whatever. I'd probably just leave it like that. Okay, another one. Yes, Marissa.
Can we do number 40 above it?
Okay. Like here?
Yeah.
Okay, so is that an 8 or a 3? What's that? 5? 5? Okay. I think we did this one yesterday. Did we do this one yesterday? Okay. And we did it 2 different ways. Which way did y'all like better?
Move it in front.
Yeah, so move the 5 out front. You can do that legally because there's a log there. So the power is here, 5. So I'm going to basically just divide both sides by 5. So I end up with log base 4 of 3x plus 4 equals 15 divided by 5, which is 3. Then I rewrite it. So I have 4 cubed is equal to 3x plus 4. And you just solve from there. So 4 cubed, subtract 4 divided by 3.
20. Yeah,
Mhm.
that's 20.
20? Okay. So that part of it I feel confident y'all can do. Tell me another one.
37.
37. Was there a question on that one?
Yeah. So for if you have basically 2 exponents or 2 terms that are raised to a power that you can simplify, would you just like simplify that out so it's easier to manipulate?
Are you saying if I had something over here, maybe?
Because don't you end up with like 4 to the 15th power and like?
Oh, if I hadn't done it that way, yes. So if I had not done that, I'd end up with 4 to the 15th is equal to 3x plus 4 to the 5th. And we yesterday used this 5th power and kind of undid that with a 1/5 power or 5th root and do the same thing here. I don't know if that's what you're asking. So then I get 4 cubed is equal to 3x plus 4. Same exact process or same exact result, just a tiny different process. Okay? Did that answer your question?
Yeah.
Okay. And it was number what up above?
37.
Or is it this one right here?
Yeah.
Okay. So for this one, do I have a common base?
6.
6. And now 6 to the what gives me 216.
3.
And then I still have an x over 3, right? Go with me?
Yeah.
And then 6 squared gives me 36 there, and then I have 2x plus 2. Is that correct?
3.
Can those
I can't read that.
It's plus 3.
So it's going to be 2x plus 3. Okay. Now, when I do 3 times x over 3, they do cancel.
Isn't that just x?
Yes, it's just going to be x. So 6 to the x is equal to 6 to the 4x plus 6, right?
Yeah.
Now, when I get to that point, I don't really even need to do all that out, but this will equal to this. So I'd subtract 4x, and I get negative 3x is equal to 6. X is going to be what? Negative 2. There you go. Okay, another one. I feel like y'all have another one.
Can you do number 5 on the next page?
Did I go the right way? This one?
Yeah.
Okay. Now, these are like 4, 5, 6, 7. They're all exponential equations. No logs are involved whatsoever. Now, we may need logs, but we don't have logs already in them. So recognize those, and you're going to do number 7. 5. Okay, all of these, you have got to isolate your power before you can take the log or ln. You've got to do that. So on number 5 here, I've got to, it's already isolated, so I'm going to do. So I can go right in and do log of both sides. So the x will come down front of log of 3. Oh, I remember this one. And this is 2x plus 1. 2x plus 1 times log of 2.
It's minus.
I cannot read that, y'all. It's so tiny here. 2x minus 1. Okay, so 2x minus 1. This is tricky, and here's why. You, in some way, you're going to have to distribute the logs. Usually, we don't have to. We're trying to do what? Solve for x's. The problem is we have unknowns on both sides. So look at number 4. See, it's different. There's only unknowns on one side, so we don't ever have to do that. So there's 2 things you can do. You could go ahead and find log of 2 and literally distribute it into these 2x and negative 1. I think that's what the key did. Or you can, this is probably what I would do, divide both sides by log of 2, cancel, cancel, log of 2, and then just think of it like this. This is just a number that goes as a coefficient of x. So go ahead and do log of 3 divided by log of 2. So log of 3.
I think your calculator's right.
Yeah, I think it has. Y'all tell me what that is. You're right.
1.58.
So you got 1.58 x is equal to 2x minus 1. That's not bad. That's not bad at all. I think that's easier than doing the whole distributing of log of 2, but you could do it either way. So then I would do what with my x's? Move them to one side. So I'd probably do minus 2x, minus 2x. Think of it like this, guys. So you're going to get what? You're going to get a negative decimal out front of x. Tell me what that is.
Negative 0.31.
0.31. So your answer should be what?
32, sorry.
32.
Okay, so your answer should be what? 0.32. Because you just divide both sides by what then? Oh, no, it's not. So sorry. So then you would divide by negative 0.32, negative 0.32, and what do you get for x?
2.408.
2.408. Do you really get that when you divide it there?
What would we play? 3, 2, 4, 2. Yeah.
Because 1.58 plus 0.42 gives you 2.
Okay, wait. What was the question?
Like,
That was straight up 2.408.
Wait, what?
like
Here,
1.
let's check our work then. Y'all, let's check it. So 1.58 minus 2.
0.42.
Yeah, that's what they're asking. Okay, very good. So yeah, let's check that. So let's kind of backtrack. So it's going to be a negative 0.42. So you end up dividing negative 1 by negative 0.42. Let's just make sure it really gives us. So negative 1 divided by 0.42. 2 point, what did you say the answer should be?
2.408. 408.
Let's go with 2.4. How about that? Because there is some rounding issues here because we had to do a little bit in the calculator. Now, if you had stored this 1.58 or just used it when you did it in the calculator, you would have had a more precise answer. It's because we rounded to 2 decimal places there. So keep your answers and just keep recalling them like I've been doing in class, and that'll help you in the calculator to get a more precise answer. But that is where we are. Okay, another one. And
Did you want
which one?
Like 4 number 6 right next to that one.
Okay.
On this side.
Okay, 4 and number 6 there. And number 4, couple ways you could do it. I would probably take the log of both sides, so I end up having log of 12, and then x minus 1 out front is equal to log of 20. And then see here, this is easy. You just divide by log of 12, divide by log of 12. And then once I get this in the calculator, I don't write it down, I just get it in the calculator and then I add 1. And that gives me the answer there. That's exact form. Number 6 is a little bit more involved. What do you have to do when you have an exponential and you want to take the log of both sides? You have to isolate the base, or the power, the base and the power, okay? So, or the power, I keep saying that wrong. You isolate the base with the exponent, which is your power. So I would subtract 3, so I end up with 2e to the x is equal to 4. Then divide by 2, divide by 2, e to the x is equal to 2. Now, you students want to take the log before it's time to take the log. So don't take the log until you can. In other words, when I'm at this point, I can't stick a log out front or ln out front at that 2. The 2 is in the way. You have to divide first. Also, another big mistake that students make. All right, so then how would you finish it off from here? Yeah, you would just take the ln of both sides. So x ln of e is equal to ln of 2, and then x is just ln of 2 in your calculator. So that would be exact, and then you could get the approximate in your calculator. Okay, now how about solving for k, using k, half-life problems, stuff like that? Y'all good with that? Okay, we've done a lot of those in class, so I've focused in a lot on those, so hopefully that'll help you. All right, tell me another one. Graphing, how are you doing on the graphing?
Just wondering,
Yes.
for the graphing, when would we tell, like, versus a normal exponential versus and a log equation when you're reflecting vertical or horizontally, depending on which.
Okay, let me kind of go over that then. That's a good question. So if you have an exponential equation, a times b to the x minus h plus k. Word problems don't usually have a k, but sometimes they do. But anyway, that's usually what we're dealing with the graphing, okay? So this would look like, and I'm just doing a general form of this, would look something like this, correct? All right. Now, if I am changing the value out front of a, it is a reflection how? It changes your y's. So it's going to make it go across the x-axis like this. So this is going to change your y values. So you know how we've been using the tables and then changing all the x's or changing all the y's, that would accomplish that. Now what if I had a negative up here? So let me just say it's like this. And if I did that, I have to change that sign. Don't worry about what I just did there. I taught you to factor out the negative. So if I have a negative here, let me do this in a different color. So if I have a negative here, it's going to change all the what values? The x values. Okay, so that means an x that was over here becomes over here, so it reflects it this way. So that is for the exponential graph. So I'll do the same thing for the log graph in just a second, once y'all get all that. Yes?
Wait, why do you do the x plus n?
It's an h, sorry.
I mean, yeah, but why would you get plus? Because wouldn't it just keep as a negative?
Well, let me show you. If you have something like negative x minus 4, and that's what, if you have this, if I had left it like that, that would be wrong. Let me explain why. Because you may think, just change the sign of that, okay? Well, here's what happens. When I factor out the negative, which you're supposed to do, you end up with x plus 4. So your translation is really 4 to the left, whereas if you leave it like this, it's 4 to the right. So let me see if I am explaining that right.
That makes sense.
Because whenever you do the factoring out, the sign changes right there. So like I said, don't really worry about that. I'm never going to ask you to do that again. But to write it in factor form like that, I needed to kind of account for that.
So I should remember if we're graphing tomorrow that it'll, instead of moving, like we move opposite of what it says it will go.
So yeah, if it's this, remember you would factor that out, and it would be a plus 4. So guess what? You're actually moving exactly like it says.
So 4 to the right then.
No, 4 to the
I mean, yeah,
This would be
48.
4 to the left, yeah.
Oh, yes.
You just read it like it's in fashion.
Yeah, that's why that probably confused all of y'all. Usually, guys, we're going to give you something like that to know it's a horizontal reflection. Okay, keeping it pretty basic. Okay, now, so let's do our logs. Now, logs are in the form y is equal to a log base b of x plus k. Okay, now, have we really done anything with a? We have not done any stretching whatsoever with logs, and we're not going to. We're keeping it pretty basic with logs. But could I have a negative out front? Yes, I could. So what would that do? So let me kind of show you. Let's remember our log function looks something like this.
You would just change all your ones, right?
Is that normal log?
This is just like the parent function. Okay? And if I have a negative here, it's changing every single y, which makes it reflect like this. So this will change the y's. So can you see that when it's out front? This is the way I always remembered it when I was in school. So y equals y. You agree the right side is y? Well, when I stick a negative out front, now it's y equals, not y, but negative y. So it changes the y. That's just a silly little way I remembered it. And then the other way you can remember it is if you have an exponent, the k. What do we do with that k? Have we had any that we have had some.
Just moves up and down.
It moves it up and down, but what if we let's see, have we had any where we did some negatives right here?
Yeah.
I think we have. Okay. So I'm just going to write it simply like that. Okay, I'm not going to do anything else with the h and k's and all that. So, well, technically, wouldn't this be x minus h? But then when I stick a negative out front, I'll just leave it like that.
Yeah,
okay?
yeah, we've done like that.
Okay,
We
so
have
that what will that
parentheses
negative
going
do
on.
right there? That negative is going to change all the x's. So if it's in front of the x, it changes the x's. If it's in front of the entire thing, it changes the y's. So when I change the x values, it's going to be a reflection how? Like this. So this one becomes a negative one, and it looks like this. Okay, so that should hopefully help you with the graphing. Did that confuse you or help you? Alden, did that answer your question?
So is that pink one log subscript b minus x log?
The pink one right here?
Yes.
That would be log some base of b, and it'd be a negative x. So the x would be negated. Go back to the graphing page that we did, and the key is online. It's a really good review, okay? Yes?
So for this one, is this reflected over y equals x, and is the other one just reflected with the y-axis, or both of them reflected over y equals x?
Okay, the only things that are reflected over y equals x are going to be when I have my exponential graph. That's really messy. Let me do it again. When I have my exponential graph, it looks something like this, growing up. And then the log graph is reflected across the line y is equal to x, because they're inverses of each other, and it looks something more like this. It's not the best job, but you get the gist of it, right?
Yeah.
So that's the only time we're talking about reflecting over the line y is equal to x. And it's only like a conceptual thing so that y'all know logs and, you know that logs and exponentials are inverses.
Wait,
That's
why is
really-
that again? Why was it?
Because exponentials and logs are inverses of each other. That was really more a learning tool, guys. We're not really going to ask you much with that, okay? That was really more a learning tool. Okay, tell me another one. Are y'all good?
How long is this quiz?
It's going to take pretty much the entire class period. So you want to come in, get your reviews out, and get ready to go, okay? Yes?
This is just like a in general question. On the quiz, if we have, like for the calculator portion, if we are given the log and we need to find out, say, the x value, do we need to write it out in the exponential form to do that? Or do we just plug it into our calculator?